in example 3b, we are going to refer back to the circle that we graphed in part A, and we're going to find the intercepts of the graph of this circle algebraically. We're going to give both the exact value, which means no decimals, and the decimal approximation of each intercept. Okay, so let's quickly refer back to the picture of the circle. So there it is. After the last video, I went and kind of perfected the circle. So remember when I graphed this circle by hand, I drew it by hand, which is all I expect you to do by making, plotting the center and then going up so many units, the number of units equal to the radius, and then going down that many units and then to the left and to the right, and just drawing your circle free-handed through those 4 points. But since we're going to be talking about intercepts and we're going to be calculating them exactly, I want our picture to be as perfect as possible so we can kind of, match our work to the picture. Okay, so if we look at this, we're going to be calculating both x-intercepts and y-intercepts. So if we first take a look at x-intercepts, this circle appears to intersect the x-axis twice. So right here, if you look where my cursor is, I'm coloring in the first x-intercept red, and then there's another one right here. Okay, the one on the left appears to be very close to x equals -9. But again, you can't really be completely sure. It could be like -8.9, or, it could be -9.1. We have to get an exact answer. Okay, you can't judge solely by the graph is my point. Okay, same thing with the right x-intercept. It appears to be very close to x equals 1. Okay, if it's exactly there, we're not sure. Okay, as far as the y-intercepts go, there appear to be 2 of those as well. There seems to be one right here, which is very close to y equals -2. And then there's another one right here, again, very close to y equals 4. Okay, so when we do our work, we expect 2 x-intercepts and 2 y-intercepts. Okay. All we have to do for this is basically apply the rules that we learned in section 2.1. Okay, the first thing I'm going to do is go back and grab the equation of this circle. Okay, now remember, we've got 2 formats of it. I have the original equation, which I've highlighted in blue, and then we have the other version, the one that I have kind of circled or put in this cloud right here with the star by it. This is the form x plus y quantity in parentheses squared plus y minus 1 quantity squared is equal to 25. That is the standard form of the equation of this circle. Okay, so that, if you recall in part A, we needed the equation to be in standard form before we could identify the center and the radius. And the original equation, which is in blue, had those 2's in front of the parentheses. And so because of those 2's, the equation was not in standard form. Okay, you can work with either format of the equation for the intercepts, either the blue equation or the one in the cloud. I'm going to go ahead and work with the one that's in standard form. Okay, so I'm going to go to the next page and write this down. So the equation of our circle in standard form is x plus 4 quantity squared plus y minus 1 quantity squared is equal to 25. Okay, so I just want to go back and check that I wrote it down correctly. Okay, all right, so this is the equation of our circle that we're going to be working with. I'm going to go ahead and box it so that we keep track of it, because we're going to have to be referring back to this equation a few times. Okay, so here it is. All right, so let's start with the x-intercepts. Okay, so if you remember from section 2.1, if you're trying to find x-intercepts algebraically, you need to set the y value equal to 0 and solve for x. Okay, so go back up to your equation up here. Okay, everywhere we see a y, we're going to replace it with 0. Okay, so we're going to get in parentheses x plus 4 squared plus open parentheses, I see a y, so I need to replace it with 0, minus 1 squared is equal to 25. Okay, so we've made our substitution. We've plugged in y equals 0. Okay, so now we need to solve this for x. And this is a pretty complicated equation. Okay, so the x is right here. Okay, it's trapped in parentheses, and that quantity is squared. Okay, so let me talk about how we're going to get through this. Okay, we need to isolate the piece that has the x. Okay, well, this first set of parentheses, this set of parentheses contains the x. Okay, and like I said, that quantity is squared. We're going to isolate this piece, and then we'll go from there. Okay, so I'm going to leave it alone for right now. Okay, and then I'm going to deal with the second set of parentheses. Inside the second set of parentheses, you have 0 minus 1. That's negative 1. Okay, so that is going to be squared. Okay, that's going to equal 25. And then if we go ahead and figure out what this is negative 1 squared. The negative sign is in the parentheses, so it is also being squared. So this is really negative 1 times negative 1. That's positive 1. Okay, so that's what's going to equal 25. Okay, again, we're trying to isolate the quantity x plus 4 squared. Okay, so we're adding 1 to it currently, so we can get it by itself if we subtract 1 from both sides. Okay, so this is going to tell us that x plus 4 quantity squared is equal to 24. Okay, so the piece that has the x is all by itself. Okay, now we've got to try to free the x from the parentheses and from that square. Okay, so you might think, okay, I'm squaring x plus 4, so let me multiply it by itself. Okay, and then go from there, and then the right side's 24. Okay, you can do that. Okay, so you could multiply out x plus 4 times x plus 4. You'd have to FOIL or use the box method. And then once you do that, you're going to realize that this is a quadratic equation, meaning the highest power of x is 2. And so to solve it, you would have to factor or use the quadratic formula. So you would have to move the 24 over so that one side is 0, because you can't factor or use the quadratic formula unless one side is 0. And so then you would go from there. If you're factoring, you would have to factor the non-zero side. Take each factor, set it to 0, and solve. If you were doing the quadratic formula, once you had one side equal to 0, then you'd have to plug into the quadratic formula. Okay, there is an easier way. Okay, so what I recommend doing in the review material for this section, okay, we talked about how to solve a quadratic equation by using the square root method. Okay, what we have been left with is something squared equal to a number. Okay, so the easiest thing you can do here, I'm just going to rewrite it. The easiest thing you can do here is use the square root method. Okay, it saves you a lot of time. Okay, so if you remember how it works, okay, again, first of all, you have to have something squared equal to a number. We have that. Okay, so to solve this, we have to first undo the something squared. So a square root undoes a square. So we're going to take the square root of the left side. So that means we're going to have to take the square root of the right side. And you have to remember, on the number part, you have to put a plus or minus sign out front. Okay. And then what happens is that on the left side, the square and the square root cancel. And so you're just left with x plus 4. So that frees the x from the square and from the parentheses. Okay, on the right, you have plus or minus the square root of 24. You absolutely have to maintain that square root sign. Okay, 24, square root of 24, they're not the same number. Okay, all right, so we are almost there. Okay, we want x by itself. Okay, so now it's easy to solve for x. If we're adding 4 to x, we undo that by subtracting 4. Okay, you have to do that to both sides. Okay, and so this is going to tell us that x is equal to, I'm going to write the negative 4 first, plus or minus the square root of 24. Okay, and so these are going to be your x-intercepts. Okay, notice you get 2 of them, and that's what we expected from the picture. Okay, you get the first one by picking the plus in the middle, and you get the second one by picking the minus in the middle. Okay, You might be wondering, okay, well, what about the square root? We did talk about simplifying square roots. So you should simplify your square root if you can, okay? Let's go ahead and check that, okay? Let's go up here and try to build a factor tree for 24. Okay, so let's see. I'll go up here to the top and let's build a factor tree for 24. 24, one pair that works is 6 times 4 is 24. Okay, and then 6 breaks down into 2 times 3, and 4 breaks down into 2 times 2. So 24 is equal to, none of these numbers, the 2's and the 3's, none of them break down any further. Okay, so we're going to go ahead and circle the numbers at the end of the branches. 24 is the same thing as 2 times 2 times 2 times 3. Okay, remember, I like to write them in ascending order and group them together, like put all the 2's together, put all the 3's together, and you can check yourself. 2 times 2 is 4, times 2 is 8, times 3 is 24. All right, so the square root of 24 is going to be the same thing as the square root of 2 times 2 times 2 times 3. Okay, so to simplify the square root, we need to find a pair. We have a pair of 2's. Okay, so that means we're going to cross out the pair. One of them will come outside of the square root symbol. Okay, and then what's left underneath, you have a 2. There's no other 2 to pair it with. There, and then you have a 3. There's no second 3 to pair it with. So 2 times 3 is left underneath the square root. Okay, so you can rewrite this as 2 times the square root of 6. Okay, so the square root of 24 is the same thing as 2 times the square root of 6. Okay, so to write our x-intercepts here, okay, we're going to write -4 plus or minus the square root of 24 is the same thing as 2 times the square root of 6. Okay, so there we go. Okay, this is the exact answer. Okay, it is not a decimal. Okay. All right, what I'm going to do, okay, because the directions did ask for a decimal approximation, okay, I'm going to write each one of these intercepts out, okay. So the first x-intercept we get by picking the plus sign, so it's going to be -4 plus 2 times the square root of 6. The other x-intercept we get by picking the minus sign in the middle, so -4 minus 2 times the square root of 6. And now I'm going to go to the calculator and get a decimal approximation. Okay, if you remember in the directions, we were asked to give both the exact value and the decimal approximation. Okay, so let's work on the first x-intercept. Okay, I'm going to type in -4 plus 2 times the square root of 6. Okay, I'm going to have to round this, so I'll probably round it to, let's say, I don't know, let's do 3 places after the decimal point. Okay, so this is going to be approximately 0.899. Okay, and then we have to do the same thing for the other x-intercept. So this time it's going to be -4 minus 2 square root of 6. Okay, so this one's going to be approximately -8.99. Or sorry, -8.899. Okay, so here we go. Okay, this is going to be our answers here. Okay, we've got both the exact answers for each x-intercept, and then we've got a decimal approximation. Okay, we're going to go back to our picture really quickly and kind of compare our answers to what we see in the picture. Okay, so this first x-intercept, 0.899 is the approximation. That's very close to x equals 1. Okay, so that's going to be this guy right here. Okay, it's not exactly x equals 1, okay, but it's pretty darn close. Okay, the other x-intercept is approximately -8.899, so extremely close to x equals -9. Okay, so if we go back and look, that's going to be this guy. Okay, again, not exactly equal to x equals -9, but very, very close. Okay, all right, so that's it for the x-intercepts. Okay, remember, if you needed to write them as ordered pairs, you would write down the x value. So like for the first one, you would do -4 plus 2 square root of 6 and then comma 0, because the y value is going to be 0. Okay, same thing with x2. If you had to write it as an ordered pair, you would write as the x value -4 minus 2 times the square root of 6, comma 0. All right, so those were just the x-intercepts. Okay, now we need to find the y-intercepts. So let's take a look. Okay, so I'm going to come up here. I'm going to put the y-intercepts in a different color so you can tell the difference between the x-intercepts and the y-intercepts. So for a y-intercept, we need to go to our original equation, which is in the box, and we need to set x equal to 0 and solve for y. Okay, so if we do that, we're going to have open parentheses. Instead of x, we're going to have a 0, okay, plus 4, close parentheses, squared, plus y minus 1 squared is equal to 25. Okay, so now we're solving for y. The y is trapped inside parentheses and that quantity is squared. So we are going to isolate the y minus 1 quantity squared. Okay, so we're going to start by working with the other set of parentheses where you don't have a variable. Inside there we have 0 plus 4, that's just 4. So we're going to have 4 squared plus y minus 1 squared is equal to 25. And then 4 squared is 16. So I'm just going to write the rest of it. All right, and now we are trying to isolate the y minus 1 quantity squared. Okay, so we're adding 16 to that. So to undo that, we're going to subtract 16 from both sides. Okay, that's going to bring us up here. Okay, we're going to get the 16s cancel on the left. We're going to get y minus 1 quantity squared is equal to 25 minus 16. That's 9. Okay, again, you have a quadratic equation, but you're solving for y. Okay, again, you could multiply y minus 1 times y minus 1, and then ultimately either factor or use the quadratic formula. But the easiest thing to do here is realize you have something squared equal to a number. So solve this quadratic equation by using the square root method. Okay, so since we have something squared equal to a number, we're going to undo the something squared by taking the square root of the left. So that means we've got to take the square root of the right side. Okay, don't forget to put the plus or minus outside of the square root of the number. On the left side, the square root and the square cancel, leaving you with y minus 1. And then on the right side, we're going to have plus or minus the square root of 9 is 3. Okay, we know that square root. Okay, and then lastly, the y has been freed from the parentheses. Okay, so we need to get it by itself. So we have to undo the subtraction of 1. So we're going to add 1 to both sides. Okay, so we're going to get that our y-intercepts are going to be positive 1 plus or minus 3. Okay, again, you end up with 2 y-intercepts. Okay, you get the first one by picking the plus sign in the middle. 1 plus 3 is 4. Okay, so you get a y-intercept of 4. And then the second one you get by picking the minus sign in the middle. So 1 minus 3 is -2. Okay, again, you could write these as ordered pairs. Okay, 0, 4 and 0, -2. Okay, we don't need to do a decimal approximation here because this is the exact value and there's really nothing crazy about these answers that we need to look at their decimal approximation. 4 is 4 and -2 is -2. Okay, but if we refer back to our pictures here, you can clearly see that this matches our picture. Okay, this circle has a y-intercept at y equals 4, and it has another one at y equals -2. Okay, so that is how you can go about finding the x and y intercepts of the equation of a circle. Okay, you're just applying methods from section 2.1. If you want to find an x-intercept, you're going to set y equal to 0 and solve for x. If you want to find a y-intercept, you're going to set x equal to 0 and solve for y. Okay, you are going to end up with a quadratic equation. Okay, and your best bet is to solve your quadratic equation by using the square root method.